Hello everyone and welcome back. Today we will go for fifth problem of equilibrium. Here a sphere of mass 20 kg, so this is sphere given that is of mass 20 kg, is resting against two inclined planes with inclination of 75 and 30 degrees. So here you can see two planes are given and this sphere is supported by these two surface. One surface is inclined at 75 degree to horizontal and another surface is inclined at 30 degree to the horizontal. Calculate the contact forces, that is reaction at A and B. So this point is given as point A and this point is given as point B, and for this point A and B we have to find the reaction. So let us first start with the problem by drawing its free body diagram. Here what I'll do, first I'll represent body as a particle. So this is a sphere. Now if a surface is horizontal and on that one of the sphere is resting, okay, and if I want to draw free body diagram of this, then we know very well that its reaction will appear as a vertical force. Why this appearing as a vertical force? Because support reaction offered by surface is always perpendicular to the surface. This I have already discussed in theory part. So that is always perpendicular to the surface. From that, can I say that here reaction will be perpendicular to the given surface, and here also reaction will be perpendicular to the given surface. Now when I want to draw free body diagram of sphere, free body diagram will start with first weight of the sphere. Mass of the sphere is given as 20 kg, then can I say that its weight is equal to 20 into 9.81, that is W is equal to mg amount of Newton. Next force is this reaction force. So since it is reaction at point A, I'll call that reaction as RA. So here I'll draw RA, and then next this reaction which is at point B, I'll call it as RB, and then here there will be another reaction and that is what? RB. So whatever forces are there in the given force system I have drawn here, and there are three forces which are forming a concurrent force system. So whenever three forces are given and they are forming a concurrent force system, I can use Lami's theorem. So here again we can go for Lami's theorem. Even the same sum you can solve with the help of the condition of equilibriums, but Lami's theorem will be more suitable. Okay, so to find out reaction RB and RA, that's what they are asking, contact forces reaction A and B. So they are asking first is RA and next is RB. So to find RA and RB, first thing that I should know is an angle made by RA and angle made by RB with the horizontal. For now, let us assume that angle made by RA with horizontal is alpha and angle made by RB with horizontal is beta. So a little observation will tell you that if I complete this triangle, then this angle will represent what? Angle alpha. So angle made by RA with horizontal, angle made by RA with horizontal is alpha, so that alpha I have kept here. Now from this triangle, okay, from given triangle, if I want to find value of alpha, okay, then this is angle alpha, this is 75 degree and this is 90. We know that sum of all angle of triangle is 180. Then can I say that alpha is equal to 90 minus 75, and that gives me a value of alpha is what? 15 degrees. Same way, when I want to find angle beta, then here I'll complete this triangle and angle made by RB with horizontal. So angle made by RB with horizontal, this angle is given as what? Beta. Okay, and in that triangle in the given triangle. Okay, can I say that angle beta is equal to 90 minus this angle is given as 30? Okay, so this is basically 30, this is 90, and we know very well that beta will be what, 60. So it will give me 30, 60 and 90 ka triangle. Okay, so once I know value of alpha and beta, we can proceed for Lami's theorem. So what Lami's theorem suggests, that in a concurrent force system having three forces and that forms an equilibrium, a ratio of force and sine of angle made by other two forces is constant. So here we are talking about a ratio of what? Force. So let us start with this as a first force. So 20 into 9.81, this is first force. Okay, so ratio of force and angle made by other two force. So what are the other two force? So other two forces, then 20 into 9.81 are RA and RB. So here I am talking about this angle. Okay, so can I write this angle as sine of, now this total angle is 180, it's a straight line, so it's 180 minus alpha minus beta. So from 180, when I'll reduce this beta and when I'll reduce this alpha, I'll get this required angle. So that's my first ratio. Next, let us take RA, that is a second force. So RA upon angle made by other two forces. So other two forces are 20 into 9.81 and RP. So angle made by these two forces is this angle, and that angle, can I write it as 90 plus beta? So here I'll write 90 plus beta, and then finally RB. So this is RB upon sine of angle made by other two forces is this total angle, and that is what, 90 plus alpha. So here I'll write 90 plus alpha. Now I know value of alpha and beta. Alpha is given as 15 degree and beta is given as 60 degree. So when I'll put value of alpha and beta over here, and by solving this first two ratio and cross multiplying it, I'll get value of alpha RA as 101.6 newtons, and when I'll go for first and third ratio, I'll get value of RB as 192.6 newtons. I hope you have understood this sum, this very simple problem where a simple geometric formulas will be helpful for you to finding value of few required angles, and once you will find that angle, it will be easier for you to put it in Lami's format, Lami's theorem format, and once you will do it, sum is very simple where we will get value of RA and RB. So this is a problem that includes sphere, which can be solved with the help of the Lami's theorem as well as with the help of the condition of equilibrium. Now your task is to solve this same sum with the help of the equations of conditions of equilibrium, and you must get value of RA and RB as same. I hope you have understood this sum. Thank you.